Good day. My name is NOPUENTE and I'm an electronics engineering student. Today, I am sharing my on-the-job training experience at Sharp Philippines Corporation, where I spent my internship working in the Research Development Department electrical team on real product development projects. This experience gave me hands-on exposure to the complete engineering cycle from troubleshooting to testing. Let me start by introducing Sharp Philippines Corporation. Sharp was founded on January 1, 1982 as a local subsidiary of Japan Sharp Corporation. For over 40 years, Sharp has been committed to improve the lives of Filipinos through life-enriching technologies. Their core values are sincerity and creativity, and you see this reflected in their product line, which includes home appliances like washing machines, refrigerators, air purifiers, and electric fans. During my internship, I worked directly with the research and development team that develops and refines this product. My internship was structured around two major projects. The first was a washing machine PCB project, where I went through the complete cycle, which are troubleshooting the original circuit, reverse engineering it, redesigning the schematic, creating the PCB layout, fabricating the board, and finally testing it. The second project was a comprehensive analysis of an AC electric fan, analyzing its PCB, identifying components, simulating the power supply, decoding the IR remote control using Arduino, and performing reliability testing. Both projects gave me exposure to different aspects of product development. Let me walk you through the washing machine project in detail. It had four distinct phases. In phase 1, I inspected the circuits, checked connections, and identified components using a digital multimeter to understand what was working and what wasn't. In phase 2, I traced all the circuit connections and created the schematic using Altium Designer. This was my first real experience with professional PCB design software. Phase 3 is involved in the hands-on fabrication work, etching the PCB boards, drilling precise holes, and soldering components. This required a lot of attention to detail and precision. Finally, in phase 4, I tested the assembled PCB to validate that it functioned correctly and met performance specifications. This project really showed me the importance of each step in the development process. The ACE fan project was more analytical in nature. First, I conducted a detailed schematic and component review, analyzing the PCB layout, identifying every component, and preparing a complete bill of materials. Next, I used Falstad Circuit Simulator to analyze and simulate the 5-volt power supply, which helped me understand how the device manages power distribution. One of the most interesting parts was decoding the IR remote control. I used an Arduino microcontroller to record the infrared waveforms, identified that it uses the NEC protocol, and determined the hexadecimal codes for each button. Finally, I performed reliability testing, measuring power consumption under different loads to ensure the product meets quality standard. Throughout this project, I documented everything with technical reports and flowchart for design validation. Over the course of my internship, I developed a range of technical skills. In circuit analysis and diagnostics, I learned to reverse engineer PCB, read complex data sheets, and use a digital multimeter for continuity testing. For PCB design and fabrication, I gained hands-on experience with etching, drilling, soldering, and understanding design for manufacturability. How to design boards that can actually be manufactured efficiently. I also developed testing and measurement skills, learning to operate oscilloscopes, function generators, and analyze signals. On the software side, I became proficient in Altium Designer for schematic and PCB layout, Falstad for circuit simulation, and Arduino for embedded systems programming. All these skills came together to give me a complete picture of modern product development. Beyond technical skills, this internship developed my professional capabilities. I learned the importance of work ethic and discipline. Every task, no matter how small, required precision and quality. I developed systematic problem-solving skills, approaching challenges methodically rather than randomly. Working alongside experienced engineers taught me the value of teamwork and mentorship. I had to quickly adapt to new tools and corporate processes. I also learned the importance of professional standards, maintaining corporate ethics, following security protocols, and respecting NDAs. And through repetitive tasks like component inventory and soldering, I developed a strong attention to detail that's essential in engineering. Looking back at my internship, several key learnings stand out. I completed two major projects end to end, experiencing all four phases from troubleshooting through final testing. I mastered five or more professional tools, which are Altium Designer, Falstad, Arduino, oscilloscopes, and function generators. I worked at a company with more than 40 years of innovation and quality in the Philippine market, learning from their standards and practices. Most importantly, I successfully bridged the gap between academic theory and professional practice. I learned industry standards and quality assurance processes that go far beyond the classroom, and I built a strong foundation for a career in electronics hardware development and quality assurance. To conclude my OJT report at Sharp Philippines Corporation, it was a valuable experience because it allowed me to apply the concepts I learned in electronics engineering to actual product development. I started with a group troubleshooting activity for the washing machine. From there, I learned how to investigate a circuit, trace connections, and understand how the different components work together. After troubleshooting, I was able to experience reverse engineering, schematic modification, PCB layout, PCB fabrication, soldering, and testing. This taught me that developing or improving a product is not only about designing a circuit, but also about carefully checking every step before the final product is tested. When I moved to the ACE Fund project, I was able to apply what I've learned from the washing machine project more independently. I studied the reference PCB, recreated its schematic, created component symbols and footprints, developed the PCB layout, and reviewed the different hardware sections. I also learned about the 5 volts power supply, AC load driver, status indicator, MCU and IR circuit, and the remote control. The IR remote analysis was especially interesting because I was able to use Arduino to capture the signal and identify the NEC protocol, 32-bit frame, LSB first transmission, and hexadecimal codes of the buttons. Another important lesson for me was learning how engineering studies an existing product. Before thinking about improvements, we first need to understand how the reference product works, what its limitations are, and how it performs. From there, possible improvements can be considered based on factors such as safety, reliability, cost, component availability, user needs, and current product trends. This changed the way I look at electronic products because I now understand that product development involves continuous evaluation and improvement. For my first recommendation, I hope that the Sharp Philippines continues providing structured and hands-on activities for future trainees. The opportunity to work with actual products and engineering processes gives students an experience that cannot be fully gained inside the classroom. My second recommendation is for future trainees. I recommend that they take every task seriously, even activities that may seem simple at first. Troubleshooting, soldering, measuring, documentation, and even repetitive tasks help me develop patience, accuracy, and attention to detail. I also recommend learning the basic function of tools such as the DMM and becoming familiar with PCB design software before starting the training. Finally, I recommend that future trainees take the opportunity to learn from their supervisors and engineers. Asking questions, listening to feedback, and being willing to learn made it easier for me to understand unfamiliar tasks. At the same time, it is important to follow company procedures and respect confidential information when working with actual product designs. Overall, this OJT helped me grow not only as an electronics engineering student, but also as a future engineer. It gave me a better understanding of how engineering knowledge is applied in an actual workplace, from troubleshooting and design to fabrication, testing, and documentation. I am grateful for the experience because it gave me more confidence in applying my skills to future electronic projects. Thank you, and that concludes my OJT presentation.